the data science. Yes, it's very vast field. Actually, it will take time. Like 2 year, what we are doing is simple. It's just like basics they are teaching, even though they are more focusing on the mathematical part. But in industry, it's not that much required until you are in research field. But you should be knowing the concept and where to apply what is the thing. Yeah, yes. See, stats is anyhow like ABCD. Okay. So if you wanted to know English, right? ABCD is the first thing, right? Same way, if you wanted to start with data science career, you should be knowing statistics, Python. These are the basics. Okay. Once you know this, like let's say if you have a use case and you have to do hypothesis testing, and if you don't know, then what you will do, right? So hypothesis testing require you to know what is p-value, what is significance level, right? And what to consider as null hypothesis, what to consider as alternate hypothesis, and then you have to uh, accept or you have to reject or do not reject the null hypothesis, right? So it's one of the type. Then you have a lot of tests like jet test, t test, right? ANOVA, ANCOVA, all these things. So basics I can say. Or the first thing I can say is the when you get data, you should be knowing the distribution of data. What is the distribution? As a machine learning guy, right? As a data scientist, we should be knowing that all the model expect that your data should be normally distributed. So the distribution of data should be normal. So we have to first check what is the distribution by using a lot of graphs, right? Like your PDF, there is one graph, probability density function. ADF is another graph, right? And there are some other graphs, more graphs, where we can show the how data is scattered, and then based on that you can know, okay, now this data is normally distributed or not normally distributed. Then you should try to convert this to a normally distributed data so that you can feed this data to a machine learning model. Okay, so these are very basic things which so I can say statistics is like keep half an hour, 45 minutes every day. Just read every day. Okay, like that until to next to 2 year, 3 year, 4 year, until you by heart the concept and you apply somewhere. Like maybe create a notebook in Jupyter, right? And just create a small use case for that and just apply that and see how the data is, what is the data distribution, because then you will be able to find that what kind of algorithm can be applied based on the data distribution. Like if it is normal distributed, not normal distributed, it's a linear, it's non-linear, what kind of data it is, right? And what is the use case? What kind of problem you're going to solve? Based on that, you can decide. Okay, seems not much people. Do you want me to start or what should I do? Okay, just I'll give a 10-minute introduction, then Monday we'll start again, same thing. Okay, since you are spending time, right? So let me give something to you. Okay. I have written a Medium blog also sometime back. Uh, yeah, deep learning just started that time, but I have written many blogs on the ML part, machine learning. So almost I've covered all the algorithms. Yes, yes, yes. Like see all these things, right? T-test, chi-square, deep learning, what to back TF, IDF, bag of words, NLP, ANOVA, this distribution, statistics, then gradient boosting, logistic regression, gradient descent, k-means clustering, all this. I'll share it to you if you want. You can share. Yeah. See, thing is there are so many blogs already written, so I don't want to bother by sharing one more thing. If people are interested, they will go explore, because it's not like this is only one thing in this. You can say, yeah, yeah, that you can they can do. I have shared you. You can share. Okay. So basically, see, if you just this is the, I can say, whole picture of your DL. So basically, artificial intelligence, right, is the broader picture, I can say. Oh, sorry, it's not visible. Uh, Shared. 1 second. Now I just shared. Okay. So basically, this is the whole picture which we wanted to share. So basically, the artificial intelligence is the broader term where the ability of machine to imitate the human intelligence, basically. So machine will behave like a human. Okay, that is the you can say the broader area. Under that we have machine learning, and under machine learning we have deep learning. So deep learning is basically a subset of AI and ML. Okay, so what is the difference between machine learning and deep learning is, see, machine learning will learn from your data, try to memorize sometimes, try to, or maybe get the information which you have, and then it will do the predictions based on the use case. Deep learning is one step further. It acts like a human brain. Okay, so how we think, right, and how we behave, how we take decisions, right, in that way deep learning also take decisions. Deep learning also work. So if I go to my blog, my blog is visible, right? Okay, so yes, yeah, statistics, ML, DL I started, then I stopped because it was taking a lot of time to write and there was no benefit. So I stopped, but I can write it more. Okay, that's not an issue. Yeah, ML statistics, DL working one or two only, not much. So basically, I'll not go with the typical definition, but you can think like it's like a human brain which works. So if you see, if somebody has studied the, you can say, MBBS, right, or doctor things, right? So they know that these kind of, you can say, neuron structures are there. So basically, in our brain, right, there are neurons which uh, take decisions and do a lot of things. Okay, so it's mentioned like in the simple term, right? AN works on the concept of neurons in our human brain. It is a electrically excitable cell that process and transmit information through electrical and chemical signals. So basically, let's say if you get cold, so how you get to know that there is a cold? Because your body, which has some pores, right, it will immediately send signal to your brain that now it is feeling cold, and your brain will tell okay that it's okay, it's a cold. Again, let's say somebody is trying to maybe pinch you with some pin or something. What will happen immediately in your any part of the body? Let's say you are going for injection. What happen immediately when they inject you, right? The signal pass to the brain. Okay, and then brain will say that now there is a pain happening, and then your body react with that. So all these things are happening based on the brains, and inside the brain, right, we have this neurons which does this basically, which does this reactions and try to find what is happening in the body. Similar behavior data scientist has tried to mimic into artificial neural network also. So this is a typical picture of your ANN. Okay, this picture where you have majorly three layers. One is called input layer. This is input layer. So basically, let's say you have a data set. So how it will work is you will give a data set. You will tell the deep learning model what to do. Like if you want to do for classification or regression or any other task, right? And then it will start working. So basically, it has input layer. So all this input layer is basically the number of features. Let's say you have 10 features, there will be 10 such input layer will be there. Okay. Now input means the number of features you're passing. That's all. Hidden layer is the internal layer. So this is the layer where actual work happens. So all the activations of neurons, right? These are called neurons basically. So these all the activation of neurons and then all the calculations and everything happens here. Weights updation basically. We'll read about weights, how it is and how to get updates here. So happening here, and this is the output layer where you will get the final output. So whether it's, let's say in the case of regression, it will be one output. In case of classification, it will be two or more, right? So that many output. So you can say input is given here, processing happening here, and then output is thrown to the this. Now, if this output is correct or not, or how near it is with the actual value, right? It is compared, and once it sees that it's not near to the actual result, there is a backward and forward propagation happens. So basically, let's say now once you get the output, right, let's say the output was 100, okay, and model predicted, let's say 70. Now this 70, the predicted value is not close, right, to the 100, right? Because generally in machine learning, around 90% we check for the accuracy, right? That 88 to 90% of accuracy, if it is there with the model, then only it will be taken for production, correct? So it will check for that accuracy. If it is not there, then it will go for back propagate. It will go for back propagation. What happens in back propagation is basically all this W I have mentioned, no, W1, W2. It's called weights. These weights will be updated due to some formula from some calculation happens. I'll tell later what equations how what some weight updates here happens, and then again it will reach till this point, and then from the final point, right, again this activation function applied, and then again it will be a new output, and then so these things, right, like weights updation, new calculation happens until it reaches to, let's say, uh, the accurate value. So let's say 100 is the right value, so it will reach up to, let's say, 97, 98. So no model will say okay, now it is good enough. And this forward and backward propagation is called epoch. So one forward and one backward propagation is called one epoch. So this value we have to mention. So when we create machine learning model, right, we mention that. Not sure if I have shown here in the code, but yes, yes, yes. No, no, it's, see, once forward means you going from here like this. Okay. Th- Which one? Okay, I've not seen that. Maybe, but see, forward, if it is only mentioned as forward, forward means you are going from, let's say, input to the output layer. Okay, that is your forward. But to justify that you are correct, it has to come to the backward also, because it may not happen that every time in first shot only you will get correct result, right? It's rare, right? Because that's how machine learning works. Because let's say you pass the input, right, it will do the calculation and it will give you one output, right? So it will not follow this backward and forward propagation. With these things, it follows the same thing. That's why it is behaving like a human, right? Because it's trying to update itself based on the values which you're passing. Okay, based on the data which you have. Okay, and what is the output? So no, no. See, for example, let's say if it is a regression use case, okay. So what we do training, right? First, so training, what happens? We pass the our x and y variables, right? In machine learning, we know which is independent features, correct? So same way, we have to pass independent and dependent feature here also. So it already knows because it's in the learning phase, correct? So it already knows that for this row, for this data sets, right? This is the output. Now there is a real value, and now there is another predicted value. There is a prediction happening, right? In the output layer. Now then we have predicted value, and when we have real value, right? It will be compared with each other. After comparison, based on the threshold which we have decided, it will come to know that okay, this is not that close to the actual. So when we know this thing, automatically this back propagation will happen. Okay, it will go update the weights. It basically there's a mathematics inside that for that part. I'll tell all this, but weight will update it, and then again same thing will come, and again there will be prediction for same row. So let's say earlier it was 70, now second time definitely it will be better because it has learned from the errors. So it will be, let's say, maybe 75. Again, it's still not close, but at least better from the last one. Again, there will be forward propagation, backward propagation, and same way it will continue up to the number of times which you have mentioned. Okay. So you have to mention like that how many epochs you want to run. Let's say 50, 100, 200, and then it will run that many times to optimize this. So I'll cover all these things very well. Okay, not very. This is one part. This is called ANN, artificial neural network. Okay. The other part is called CNN, convolutional neural networks. Okay. So basically, now this deals mostly with the pictures, I can say. Okay. Like if you wanted to, based on the picture, I tell, is this picture of cat or dog, right? So how you'll decide based on the convolutional layer. So there is an additional layer in this structure, in this architecture, which will decide, which will help you to decide there is a image, what image it is. Basically, cat, dog, girl, boy, right? Depends on. So this convolutional neural network comes handy there. So again, there will be a set of convolutional operation which is happening to decide the edges of that picture. The, let's say if there is a human, right, or any animal, where is the eyes, right, where is the nose, lips, right, all these things. So it will try to detect those edges, and then it will finally find that okay, this is like a dog or cat or human, or maybe like girl or boy or something like that. So this is your CNN. Recurrent neural network is like your the third form of deep learning, okay, where it, you can say, learn from the statements. Let's say you have a review system, basically restaurant review system, where somebody has given a negative feedback. Okay, so what it does is it will try to get the information, the feel or sense of from that statement, and then tell that okay, this is a negative or positive. For example, let's say if I'll tell ki this food is not good or this food is worst, then worst is a keyword, right? Where to find that okay, worst mean bad. But if I'll tell this food is not good, okay, I mentioned not and good, right? So this confused uh, the ML operations. Okay, so it has to remember the context. Okay, then in what context we are talking about, and it was through this context, remembering the context and then predicting, right? These things happen here in RNN, recurrent neural networks. Okay, there is a lot of things happening in these two areas, even here also. But like I said, no, that initially that if you want to spend your whole career into CNN, like if you, let's say, you may be working with a company where it's tried to predict the how human body languages, right? Let's say you created a software where if someone is behaving abnormally, right, he may be a culprit for something, correct? So based on the body movement, based on right, you can decide it based on. So you can create a model which can decide that this is a culprit or not based on the body movement using CNN. Okay. So all these things will go. Yes, 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 right. Yes. Mm-hmm. Come again. You can say like this, but there again a broader picture also because it does a lot of things in RNN, a recurrent neural network. Okay. So I'll talk more on this when I'll take, but currently you can say all these three fields are basically trying to behave like a human. Okay. How human is behaving, how human, like let's say when you're a child, right? How you come to know this is not good or bad or this is wrong or right? Let's say you are trying to touch any thing which is hot. What will happen? Your parents will say, okay, don't touch. This is not good. It will burn. It will hurt you. So, or maybe by mistake you touch, you will get maybe some like heat, right, in your body, fingers, right, and then you will learn. Okay, no, it's not. I cannot touch because it is heat, hot. So basically, you're learning from those experiences, right? So that kind of human things are happening. Same way, all this is working. Okay. I'll cover Monday. Okay. In more precise way. We'll talk more on this. Okay. Hmm? Yeah. See, it is an advanced version of ML. You can see because it try to mimic behavior of a human compared to what ML. ML try to learn from the data, but it's an advanced version of, you could say, ML. Okay. That's why it's called deep learning. Hmm. Yes, yes, yes. So you can understand that there will be only one forward propagation in ML where once it is input is provided, operation will some happen, and then you will get output. That is the final thing. Okay. But in deep learning, it will be multiple backward and forward propagation happens. That's way. That's how it optimizes. That's why you see, right? Generally, in deep learning, right, you will not find any underfitted model. Mostly, most of the models are overfitted or good models. Okay. Underfitting doesn't happen generally in deep learning. Mm. Mm, 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 mm. S- Don't worry, I will take. See, simple dropout means let's say you have 10 features, right? You are passing this in input layer, okay? Now the hidden layer, which is inside input layer and output layer, right? So what it does is there is neurons, okay? So if you say that, let's say out of 10 neurons, you switch off some 40% of neurons every time when some kind of operation is happening. So randomly what it does, right, when the operation happens randomly, it will switch off this 20, 40% whatever amount of information you mentioned, right, to switch off. It will switch off that so that those neurons will not be active. So waits updation time, right, uh, that will not contribute, I can say. And why we do this dropout and all? Because there are a lot of overfitting happening because your data is that much overfitted that it is not going to work with the real data. Okay. So to avoid overfitting, we do a dropout layer. Okay. There are two kind of, I can say, regularization or techniques. That is a different, I can say, two different concepts altogether. I can take. Uh, I'll take that actually when I'll do regularization. Okay. Just wanted to start from the beginning, no, so that even people who does not know anything, they can also understand. And only thing is my time here, that is not is a problem. Okay. Generally 9:30 I can think, which is good for me for 45 minutes because I sleep by 10:30. So I am thinking to take 45 minute of session, and that's what. So every day it's not possible, but yeah, I'll try to take 3 to 4 sessions per week so that we can complete that. Okay, in a month's time. Okay. Monday I'll take that. Yeah. Okay. Okay. Mm. Okay then, Manoj, we'll meet Monday. Okay. Okay. Thank you. Thank you, Aman. Bye.
Thank you.